The analysis of variance, or ANOVA methodology, as it's commonly abbreviated, is an incredibly important topic to dedicate time towards understanding. I say this as the ANOVA is either a top 3 or top 5 method in frequency of application. As from my experience, typically the t-test is number 1. However, there are instances in which the t-test is not appropriate, and in those instances, typically, the ANOVA tends to be the alternative application. Just like the t-test, for the ANOVA lectures in this playlist, I've split the subject matter across multiple videos. The reason for such, although the ANOVA is a commonly applied methodology, it is also frequently incorrectly applied. Therefore, if you ever find yourself in a situation in which you believe the ANOVA to be the appropriate method, be sure to take your time in structuring your data and deciding if the ANOVA test is appropriate for your research needs. In this lecture, we are going to specifically discuss the one-way ANOVA and Tukey's HSD post-hoc analysis. So ANOVA is used to compare the variances of various sample groups against one another. In many ways, it is similar to the t-test. However, ANOVA allows for multiple group comparison. This differs from the t-test, which at most only allows for one single group to compare it against another group. Now, like the t-test, there are different variations of the ANOVA model that are applicable depending on the data being analyzed. We will review 2 common ANOVA applications as they pertain to various data types. And in this video, again, we're only reviewing the one-way ANOVA. So here are our model assumptions. We're going to assume that each sample is random. Each sample is in no way influenced by the other sampling results. Each dependent variable is sampled from a normally distributed population, and the variances of the samples should be equivalent or somewhat equivalent. And the reason for such is the population variances are assumed to be equal for each sample. And you'll notice if you've watched the t-test lecture that many of these assumptions are the same. So here is the hypothesis for the one-way model. We have the null hypothesis being the mean of 1 equals the mean of 2 equals the mean of 3. And you can have multiple means depending on how many groups you have. So in this case, we have low salt, and we'll go over this data set in our example in the subsequent slide. But in this case, we have low salt, medium salt, and high salt. So we have 3 groupings. So therefore, our null hypothesis in this case would be mu of 1 equals mu of 2 equals mu of 3. If we had another grouping, we would have mu of 4. The alternative is not all means are equal. So in this case, it's 1, 2, and 3, and that's it. But if we had 4, we would have it here. And if we only had 2, it would be mu 1 and mu 2. And that depends on the number of categorical designations. So here is the example that this data set is going to be utilized for. And as always, all the code and data samples can be found in the video description, although they're in CSV format. So you'll have to reconvert them on your own and import the data into your RCommander to follow along. But in any event, a chef wants to test if patrons prefer a soup which he prepares based on salt content. He prepares a limited experiment in which he creates 3 types of soup: soup with a low amount of salt, soup with a high amount of salt, and soup with a medium amount of salt. He then serves this soup to his customers and asks them to rate their satisfaction on a scale from 1 to 8. And we're assuming an alpha of 0.05. And here are the ratings below. A one-way ANOVA equations do not have to have column observations of equal length. So as you can see here, there are only 3 observations for low salt. There's 3 observations for high salt. And for medium salt, there are 4. So in one-way ANOVA, the categorical groupings can be of different length. And as far as these categorical groupings are concerned and how the data has to be structured for the RCommander to appropriately be able to apply the one-way model methodology, it has to be structured in a model which is similar to what we have here. So here is how we're going to apply the one-way ANOVA methodology. From our RCommander menu, we select Statistics, Means, One-Way ANOVA. Our response variable is going to be ratings, and our group variable is going to be SALT. You can set the confidence interval to whatever you believe is necessary as it relates to your research. In this case, our alpha value is 0.05, so our confidence interval is 0.95. That typically will be the case, but if you're working with something a little bit more exotic and want to change it, you would change it in this box here. So click OK once you have this achieved, once you have your groups designated and your response variable designated. This is the output that we would receive in our console for this particular example. So if you were to follow these steps along on your own and you appropriately apply the methodology by following the prior steps, you should end up with an output which resembles what is here on the screen. So this value here is our p-value. And as you can see, our p-value is greater than our alpha value of 0.05. So we are not going to reject the null hypothesis. These other values that I have highlighted in yellow, these values are going to be useful in reporting our data in APA format. So if we're just going to explain in regular terms what it was that we were able to discover from the application of this methodology, we would say that at a 95% confidence interval, because remember, alpha equals 0.05, we cannot state that through the analysis of the data provided, that there is a significant difference of customer satisfaction as it pertains to salt content in soup. So here are the values in our output, and here is how they would be placed within the appropriate APA format if we wanted to publish our results or report them in a professional manner. There is not a significant effect of salt content on customer ratings of the soups at the P is less than 0.05 level for the three conditions. There are three conditions because there were three different soup types. Remember, low salt, medium salt, and high salt. Here's the degrees of freedom for salt. Here's the degrees of freedom for the residuals. Our F value is placed here. It's given two significant figures. And our P value is placed here. Again, two significant figures. And again, because our P value was greater than our alpha value, we did not reject the null hypothesis. So there is not a significant effect on salt content of customer ratings of the soup. So customers more or less rated the soups about the same, regardless of salt content. Now, I wanted to demonstrate a Tukey's HSD post hoc analysis. And the way to do this is we have to, we ought to find significance before we apply this. So I've come up with, I don't have a word problem for this. We're just going to use this data here. And this data is in the CSV format in the video description below. It's going to be the same sort of hypothesis. In this case, we have group A, B, C, and D. So we'd have the mean of group A, the mean of group B, the mean of group C, and the mean of group D, all equaling one another. That would be our null hypothesis. And our alternative hypothesis would be not all means are equal. So don't really be concerned about what this is actually representing as far as a word problem example is concerned. We're just going to run the methodology so I can show you how the Tukey's HSD post hoc is applied and how to report it in APA format and what that actually is demonstrating as far as the output is concerned. So remember, and we discussed this in the slides as it relates to the t-test, if we were to run a t-test similar to what we're seeking to achieve with this ANOVA, we would have to run multiple t-tests. So let's say we wanted to compare group A to group B, group A to group C, and group A to group D. and group B to group C, and group B to group D, and group C to group D, well, we'd have to run 1, 2, 3, 4, 5, 6 separate t-tests. And of course, that's going to increase the probability that an error occurs with each test that we run. But we can avoid this by utilizing a one-way ANOVA. So that's what we're doing here. So just keep this in mind because this will become useful as we get into the application of the Tukey's HSD. So instead of running multiple t-tests, we're going to run a one-way ANOVA model. And in this way, we don't have to deal with Bonferroni, and we don't increase the probability that an error is created. So let's go ahead and run this particular bit of data through RCommander and apply a one-way ANOVA. So we're going to go to Statistics, Means, One-Way ANOVA. Our groups are going to be group. The variable name might not always be this simple, so make sure that you select whatever the group name is for your particular grouping variable. Our response variable is going to be rating. Again, it might be something different depending on how your data is structured. We're going to be using an alpha value of 0.05, which is a corresponding confidence level of 0.95. And in this instance, we're going to select pairwise comparison of the means. This is going to give us a bit of additional output in our console window. So let's go ahead and click OK. So here is the output as it pertains to the prior data that we had applied a one-way ANOVA to. As you can see, we also have our degrees of freedom for the group and the residuals. Remember, we had group A, group B, group C, and group D. Here's our F value, and here is our P value. Now, assuming our alpha value was 0.05, our P value is less than 0.05. If we round to two significant figures, it would be 0.03. So in that case, our P value is less than our alpha value, so we reject the null hypothesis. We reject the null hypothesis because our P value is less than our alpha value. So there is a significant difference as it relates to the rating scores as categorized by groups. Now, this creates a bit of a conundrum because we know that there's a significant difference as it relates to these various categories and their ratings, but we don't know where the significant difference was. Was it A as measured against B, A against C, A as against D, if these were t-tests and we were comparing A to B, A to C, A to D? Was it B as assessed to C, C as assessed to D, B as assessed to D? We're not sure. All we know is that there was a significant difference there. So we need to go further. And this is where the Tukey's HSD post hoc analysis comes into play. Now, there's various post hoc analysis methodologies which you can utilize. Tukey's HSD is a common post hoc methodology of analysis. So in most cases, as far as doing research for publication, unless you're doing some sort of nuanced exotic analysis, you're going to utilize Tukey's HSD to perform post hoc analysis on a one-way ANOVA. And you only need to apply post hoc analysis, Tukey's or otherwise, if you come to a p-value which is less than your alpha value. Okay, so we rejected it, and also where is the differentiation? Which categories? So because we checked this box here, we have additional output. And this is that additional output which appears in our output console in the RStudio interface. So we have different p-values. And on the left over here, these are the group comparisons, 1-to-1. So this is, remember, A versus B, A to C, A to D, B to C, B to D, C to D, as it was in this slide. So we know there's differentiation. This slide here, this output will indicate to us where the differentiation was. So as you can see, this value, B as compared to D, or D as compared to B, as it were, depending on whether you'd like to read it left to right or right to left, D to B has an alpha value at two significant figures of 0.04. So therefore, we can determine that the differentiation occurred if we're utilizing an alpha value of 0.05 from D category as compared to the B category. Now, there are instances in which you may have actually multiple categorical differentiations which are significant. So it doesn't necessarily always mean that you'll have just one categorical comparison which is significant. You may also have, say, A to B or A to C. It all depends on the data. So you have to list each group comparison that was significant as based upon the p-value for your Tukey's HSD if you're publishing your research results. So we have to go another couple steps now before we can report our data in APA format. If we're still using RCommander, we need to get the means of the groups and the standard deviations of the groups. So first we'll go about getting the means. So we're going to go to Statistics, Summaries, Table of Statistics, and our mean is going to be selected as far as the statistic option is concerned here. Our factor is going to be our group. Our response variable is going to be the rating. And if we click OK, that provides us with the mean of each group. So the mean of group A was 5.48. The mean of group B was 4.92. The mean of group C was 6.09. And the mean of group D, if we round it, is 6.47. Okay, and what that is let me just go back just so it's clear. You made it this far, right? That is the mean of all the ratings for group A, the mean of all the ratings for group B, the mean of all the ratings for group C, and the mean of all the ratings for group D. So those are those values here. But we're only interested in B and D because B and D are the categories that Tukey's HSD post hoc analysis indicated there being significant differentiation. Now we need to do the same for the standard deviation of the groups. Statistics, Summaries, Table of Statistics. Our factors is group, our response variables is rating, and we're going to choose standard deviation for our option and click OK. So this is the standard deviation of group A, group B, group C, and group D. We're only interested in group B and group D. And again, that's because of the Tukey's HSD post hoc analysis output. So we're about ready to now report our findings in APA format. So let's go ahead and do that. And we will say that there was a significant effect on group designation on the reported scores at the p less than 0.05 level for the four conditions. The four conditions are the four groups, A, B, C, and D. For the output, these were the degrees of freedom for the groups, degrees of freedom for the residuals. This is our F value to two significant figures, and this is our P value, which as you can see, 0.03 is less than our alpha value of 0.05. So now we're going to report the post hoc analysis findings. Where was the differentiation? We can see that there was a significant differentiation between groups, but where was that differentiation? So we will state post hoc comparisons using the Tukey's HSD test indicated, and remember, there's multiple post hoc methodologies which can be applied. We're going to use Tukey's HSD because it's probably one of the most commonly applied post hoc analysis methodologies. But in any event, post hoc comparisons using the Tukey's HSD test indicated that the mean response score for group B category mean 4.92 standard deviation equals 1.98. That's what the values we received from the prior slides, was significantly different than the group D category mean 6.47 standard deviation 1.60. Now, there are instances in which, and this is rather uncommon, but it does happen. It didn't happen in the event of our findings for our output and our analysis for the last example that we worked through together. But in case you ever happen to run into this, don't freak out. I'm just going to cover this in our last slide, and then we're done. You've made it this far. There are instances where you will find a statistically significant differentiation for your one-way ANOVA, and you'll run a Tukey's HSD test, but you won't find any of the comparisons of the groups to be significant. So you won't find any of these values to be significant at a particular alpha value. So if our particular alpha value is 0.05, this value, let's say all these values are the same, and this value is like 0.0579. Well, in that case, we do have significant differentiation as it pertains to our findings for our one-way ANOVA, but our Tukey's HSD did not have any findings or display findings as it pertains to any of the output results. So again, we're just pretending that this value is, I don't know, 0.0579, okay? Different hypothetical. So if that were the case, we would report our Tukey's HSD post hoc analysis findings as thus. So we'd have our regular output findings in APA format for the one-way ANOVA, and our post hoc analysis would be post hoc analysis using Tukey's HSD test revealed no significant pairwise differences between the groups, all p-values greater than 0.05. So this is uncommon that there won't be a statistically significant finding found in the post hoc analysis, but there was a finding in the one-way ANOVA, but it's uncommon. So if you run into that, report your results as such, and this will cover you as far as the APA format is concerned. And then you might want to do a little bit more research yourself, just so you have an understanding as to what is actually occurring when you do run into this uncommon situation, in case you need to discuss it with your methodologist or fellow researchers. So if you made it this far, congratulations. I know that this was a long video, but it's a very important topic and a commonly misapplied and misunderstood topic. Best of luck with your research. Best of luck if you're in a course and you need to understand the content which we covered in this particular lecture. If you could, on your way out, consider liking and subscribing. It would mean a lot. And with that, I will leave you to your research. Take care and thank you for stopping by.